Okay, so now we look at exponentials, we can look at something called a logarithm. And a logarithm is just the inverse of exponentials. And they're written like this, as I've shown here. And you read it like the logarithm n to the base a is x. So that's how you go about reading it. And as I said, it's the inverse of an exponential. So for example, if a to the x is equal to n, then I can rewrite it like in this kind of form. So an example of this is, well, if we have maybe 2 cubed is 8. If I were to write this in log form, then I just write it as log 8 to the base 3 is equal to 2. Okay? Maybe you can say like 3 squared is 9. Then I say log 9 to the base 2 is equal to 3. Okay, so that's how you go about writing or converting from exponentials to logs. So I can do the opposite way around. So if I have maybe log 125 to the base 5 is 3, then this is equivalent to saying 5 cubed is 125. So you should be very comfortable in going back and forth between exponential form and the logarithm form. And from here, we can introduce some log rules. So we have something called a multiplication rule. We have a division rule. And we have a power rule. The multiplication rule states that if we have maybe log ax plus log ay, so the bases are the same, they're both a, then you can combine this to say log a x times y like this. So you multiply x and y together. The division rule is when we have the same base against log ax minus log ay now is a negative. In this case, it becomes log ax over y. And the power rule is if we have like n log ax, this n I can introduce or bring it up to the power. So I would say it's log x to the power of n base a like this. So these are 3 rules that we need to be very comfortable with because it allows us to manipulate logs. We can join logs together, we can separate logs and just make our lives much simpler when we have to find solutions later on. We also have a couple of other terms which you have to be aware of. So if I have maybe like log a to the 1 over x, this is going to be equivalent to log a x to the power of minus 1 using indices, right? And if I were to use the power rule, this minus 1 I can bring to the front and rewrite it as minus log a to the x. So this is another, it's not really a rule, but it's like a value which you should be aware of. Other stuff would be maybe log a to the base a. This is equivalent to 1, and log 1 to the base a would be equivalent to 0. So these 3 here, these start ones here, are just some terms which you should be very comfortable with and just try and memorize it as well. Right, so let's try some of these questions here. We have to like combine them into single logs. So let's try D. So log 25 base 8 plus log 10 base 8 minus 3 log 5 base 8. So as I said, these rules only work when the bases are the same. As you can see, they all have the base a, so we can apply these rules. Right, first things first, this 3 here, we can use the power rule to bring it up to here, right? So I can say it's equal to log 25 base 8 plus log 10 base 8 minus log 5 cubed base 8 like this. And now I can use a combination of the multiplication rule and the division rule. So we're going to combine them into 1 log of base 8. And because this is plus, we're going to multiply 25 by 10. And minus means divide, so we divide it by 5 cubed. So we'll get log 8 250 over 125. So this is going to be log 2 base 8 like this. Let's try another one. Let's try E. So let's say we have 2 log 2 base 10 minus in brackets log 5 base 10 plus log 8 base 10. Once again, they're the same basis, so we can apply the rules. This 2 I'm going to bring up here before I do the multiplication and dividing rule. So this is going to be log 2 squared base 10 minus, I'm going to combine this now. So log 10, this is plus, we're multiplying, so 5 times 8. So this is going to be log 4 base 10 minus log 40 base 10, which I can now divide, so log 4 over 40 base 10, which is equivalent to log 1 over 10 base 10. Now remember from one of the tips we said earlier, right? If it's a 1 over, I can rewrite this as minus log 10 base 10. And log 10 base 10, if you look back up here, log a base a, anything like that, is always equivalent to 1. So I can say this is equal to -1 like this. Okay. Right, let's try and solve some questions. So let's say we have 2 to the x is equal to 10. So we're trying to find that x. So the way we find the x is we convert it into log. So this will now change into log 10 base 2 is equal to x. And the way we work this out is we use a calculator. So you should see in the calculator there's a log function button. And you can see like you can change the base and the values as you would want to. So if you plug in log 10 and change the base to 2, and press equals, then you get our x solution here. So x is equal to 3.32. Okay, let's try another question. Let's try maybe 7 to the power of 2x minus 1 is equal to 23. So I want to change it into log form first. So this will convert to log 23 base 7, which is equal to 2x minus 1. I'm now going to rearrange for x. So we'll have x is equal to a half log 23 base 7 plus 1, which I can plug into the calculator again to get your value, which will come up to 1.31. Maybe let's try one more. So let's say 3 to the power of 2x plus 1 minus 26 times 3 to the power of x minus 9 is equal to 0. So this looks kind of different, slightly different, right? But first things first, if you have 2x plus 1, I can change it using the industry rule and rewrite that as 3 times 3 to the 2x minus 26 times 3 to the x minus 9 is 0. And this, if I say let capital A equal to 3 to the x, and substitute for a, we'll get 3a squared minus 26a minus 9, which now looks like a quadratic graph, meaning we can now factorize. So if we were to factorize 3a will have minus 9 plus 1 is equal to 0, meaning a is going to be equal to negative 1 over 3, and a is 9. So we found the a values, but we're trying to find x. So what we can say is, well, a is 3 to the x, right? So therefore 3 to the x is equal to negative 1 over 3, and 3 to the x is equal to 9. Trying to find x, well, we can do the log thing, right? So we'll have x is equal to log minus 1 over 3 base 3, and in this case x is log 9 base 3 as well, right? And this we get 2, but if you plug this one into a calculator, you'll actually get no solution, or you might get an error. The reason being is because we can never have a negative value inside our log, okay? But a log can never be negative inside. The log total can be negative, but inside we can never have a negative value. So the only solution we'll get is this 2 here. Let's just try one final one. So let's say we have 7 to the power of x plus 1 is equal to 3 to the power of x plus 2, like this. Now this is a slightly different one, okay? So this is, we can't change the log straight away, but what I can do is apply logs to each side. So I can say that log 7 to the power of x plus 1 is equal to log 3 to the power of x plus 2. Note, I haven't written a base down, right? Because I can just assume it's the same base. So in the calculator, you will see a log button without any bases. This is the equivalent to log base 10, okay? So if they don't give you a base, right, you don't have to use a base, but you can just use this classic log button that you see on the calculator. So in this case, now I can use the industry rule, and I can say that, well, x plus 1 times by log 7 is equal to x plus 2 times by log 3. Multiplying out the brackets, x log 7 plus log 7 is equal to x log 3 plus 2 log 3. Moving all the x's to one side, so x log 7 minus x log 3 is equal to 2 log 3 minus log 7. I can now factorize the left-hand side, so x log 7 minus log 3 is equal to 2 log 3 minus log 7, and divide to leave me with my x value. So 2 log 3 minus log 7 over log 7 minus log 3. So I'll just use, and I can plug this into a calculator to find my x value. So I'll just use the log rules and the industry rules and manipulate it, move the left and right, and then factorize. So as you can see, to solve all these different types of questions, just be very aware or very familiar with these log rules. So maybe go back to the log rules, the 3 log rules, and just try and memorize these log rules, or just try and solve questions involving these log rules.